Am I live? Yeah. Okay, good afternoon, everyone. Thanks very much for kind of coming along. I was kind of having a chat with Amanda, what was it, probably last week, kind of thinking about, well, what should we call this session? So we've given it a hopefully alluring title, and then hopefully you'll get some kind of interesting content coming out of it as well. So this is kind of brand new, debuting here at Angus Council, reacting now and predicting the future, how data will change our services. So that's what I'll be kind of covering today with, as it's kind of said in some of the preamble, a bit about big data, a bit about artificial intelligence, and a bit about how it really can make a day-to-day difference to how authorities are delivering services. So, who am I? This is me, in the flesh. So I've been working kind of in and around local government for just over 10 years now, including a kind of stint as the IT director at London Borough of Sutton. At the moment, I'm the Chief Operating Officer at a company called Angus Global. We're based down in Cambridge, very much focused on using new technologies to help the public sector do better at the important things that it does. But I'm not particularly going to talk about that. However, I probably will kind of go a little bit into my wider experience, which includes some private sector examples. So if I start kind of drifting out of the public sector, it's certainly going to have been influenced by that. And as it says there, I could have done an entirely technical session on the comparison between different machine learning heuristics and how it is that the page rank algorithm that Google uses has matured over time. But I'm not doing that because actually the technology, sure, it's great, it's exciting, and for people like me that work in it, it can really kind of give you a buzz. But the thing that I think most people here are interested in, and certainly the people on the street that you're supporting are interested in, is, okay, well, how's it going to make my life better, directly or indirectly? Okay, so let's kind of get started. So the first thing to say, and you'll probably feel this kind of naturally, is that humans just love organizing information. So the earliest example that has been kind of touted as the first kind of records that mankind was making was around about 18,000 BC, so this bone was found in Congo in about 1960, and it's got an array of strange markings on it, which people are saying is the beginning of a kind of numbering or tallying system. And actually, on one side, all of the tally marks are prime numbers. So maybe this is early mathematics in action. However, at the other end of the spectrum, there are anthropologists who are saying, no, it was just to make the stick easy to grip. So you have to take what you want from that. Abacuses came around just sort of a couple of centuries before Christ, and most early kind of use around in Babylon, and that was really the start of trying to organize information into libraries, trying to be able to do repeatable calculations in order to kind of keep track of things. So by 300 BC, Egypt was making strides ahead. The Library of Alexandria was built. At the height of its power, I was going to say, but the height of its knowledge or content, the estimates are there were up to 300,000 scrolls of information in that one library. Now, what happened was Julius Caesar turned up with his army and accidentally burnt down a decent proportion of it. So that tells you something about retention policies and the importance of disaster recovery even back in those days. And of course, my favorite, and I'm sure yours as well, Microsoft Excel. So when it kind of landed, what was it, probably about 1986 or something, I think was one of the early versions of it, that has really taken hold of business in an enormous way. So I said I'd talk a bit about private sector examples. I did a project with Royal Sun Alliance Bank, insurance, around about, that was probably the start of my career, sort of 15 years ago, and we did a quick audit and found 10 million spreadsheets on their shared drives, which, so if you think you've got a problem, you're only just getting started. But people love Excel, and it's because it's powerful, it's because it allows you to organize information, it's because it allows you to show off how good you are at formatting, and it's just a good way of, and the reason it's so popular is because people just love getting stuff organized and making making the information work for them. So we'll fast forward, quite 2,000 years now, to 1970. So this was a really, really big and important year. And it's because this man, he was working at, this is Edgar Codd. He's an English guy, and he was working at IBM at the time, and he kind of sat down and said, actually, yeah, the information that we're organizing is starting to get a little bit out of hand. I feel like our data structures, we're repeating the same information again and again and again and again. So what is it that we can do about it? Well, there's a more efficient way in which we could be working, which is to organize it into a relational database. So this is a kind of, the simplest example of that is that you'd hold the information on Angus Council once and say, okay, this is the name of the organization, this is its address, here's the main switchboard number, but then everyone in this room would just have their own record related to that. So you wouldn't store all of that information. Again, you'd just say works at, and then Angus Council. So you can imagine, that's immediately saved you keeping that information up to date in whatever this is, about 50 different places at the same time, and giving you enormous kind of storage efficiencies. And so, when people kind of talk about Oracle or SQL Server or Microsoft Access, another favorite, then it's really kind of thanks to this guy in the early work that he did. So, and actually, this model of IT has done us pretty well until around about 10 years ago, when you can see we're not even on the graph. So what this graph is showing is, well, how much data is it that is stored in the world? And it's obviously an estimate. No one has genuinely gone around and counted it. But you can see that the number of exabytes, so that's billions of a gigabyte, or 10 million iPhones per one of those. That number is just kind of starting to grow exponentially, kind of starting off around about a decade ago, and then it's been kind of growing steadily, with a big shift from you can see the blue line, which is the structured data, which is what will have been going into Edgar Cobb's relational databases. Yeah, that's growing a lot, but what's really taking off is all of the unstructured data. So this is everything which you couldn't neatly put into a database and say, oh yeah, the information is always in that format. And there's a kind of quote there, so this is from back in 2011, just kind of making the point that actually, we've kind of gone from the dawn of civilization to 2003, that's quite a lot of data. We're thinking maybe he was thinking maybe 5 exabytes, and then we're shifting to that every 2 years. So it's an enormous shift in the volume of data that's being generated. And this is why people talk about big data, is because it is a lot bigger than it was back in the 70s when the fundamentals of databases got put into place. So what's driving it? And it's not a lot of people just sat in an office typing away in their computers going, let me just make some data. The big thing that has changed it is the internet. So you probably won't be able to read a lot of this spiral, but this is just kind of running through some of the kind of key stats on levels of usage of each of these different services, and they're all kind of household names now, every minute. So Google, for example, processes 3.7 million searches on the internet every minute. And you think every one of those is an imprint, a bit of data that's being created. And actually, so the really impressive thing about that is not that they can do is that 3.7 million searches is trawling through 130 trillion pages, web pages that are available that could be indexed and could be returned. And if you think about, well, how quickly is it being able to give me usable results from across 130 trillion pages, it's pretty impressive. And Google and their PageRank algorithms and MapReduce, they were one of the big early proponents of saying, look, we're going to need a different way of doing this in order to cope at this scale. And their continued sort of dominance in the search market shows that they've really got it right then, and have continued to invest all the time since. The other thing that's happening, and that's really got no contrast at all, is that, so in 2008, there was what's labeled on there as the inflection point. So that was the point at which the number of devices, and I think this was mostly focused on mobile phones, exceeded the number of people in the world. So that was where we kind of went from actually, there's more people than there are kind of electronic devices connected to the internet, to actually, no, there's more devices than there are people. And you can see that this is actually going to kind of continue to grow. So, earlier Andrew was mentioning Alexa. Every time anyone buys one of those and puts it in their house, you're then up to 2. And then, you've got a work phone as well. Okay, you're now up to 3. You've got a smart TV that allows you to watch Netflix without needing to log on to your computer. You've now got 4. And this is, and that's not even touching the array of sensors which are starting to get placed out in the environment. You could put a sensor in a bin and see, is it going to be full? You can have sensors in roads, street lights. There's some good examples over in the corner of sensors that can be fitted in the home. And you can kind of see how each of those, or the Internet of Things is what this is often referred to as, is going to just continue to drive an increasing amount of connectivity. And with connectivity comes a flow of data. And then you're back to this chart here, where you're really kind of starting to see everything skyrocket. So that's what the big kind of data revolution is really about. And it's obvious that, Excel, I'm coming back to it, they've been doing their best. And actually it was, from my point of view, it was a dark day in 2006, I think it was, when I found out that they were going to increase the maximum number of columns. Because what they've really done is said, oh, it's fine, let's just continue to proliferate unstructured data in tools that aren't really designed for it. But even that generous, what's that, times, kind of 20,000-fold increase in your capacity isn't going to cope with the type of changes we were seeing on the other side. And actually, you look at the maximum number of columns here, 16,000. SQL Server, it's only 30,000. So the relational databases that I was talking about earlier, they can only really cope with, they can cope with larger volumes, but they can only really cope with starting to double the complexity of an Excel worksheet in terms of the number of dimensions of information that you're dealing with. So when people talk about big data, it can be big in any of these 4 ways, really. So volume, which is what I've talked about mostly so far. There's a bit about velocity. So, I was kind of saying, actually, just the sheer number of these things pumping data means that this idea of I'm organizing every bit of information as it comes in starts to break down. So it's another strand of big data thinking. There's variety. So, people aren't, a photo of my daughter that I put on the internet is not going to be in any way the same as a photo that you put on the internet, or my scrawlings on a blog or a tweet or a Facebook message. It's not, oh, here's a validated form, please structure your comment on how you feel about Britain's Got Talent into 10 easy to digest and easy to analyze bits of information. It's just, here's my stream of consciousness, I'm just going to chuck it out there and see what happens. And then, of course, there's veracity, which is really kind of goes along with all of this stuff, which is you just don't know what you're going to be getting. A lot of it can be junk. The sensors might be broken. People's opinions might be worthless to you. There's going to be a lot of things which are going to be coming through which just are going to be noise in the overall scheme of things. And so that's the other big kind of strand of it is, well, how do I cope with that differentiation? So that's kind of the big data context. Just kind of coming back to the point I made at the beginning, really, you can have a session which just really kind of talks about, well, what are all of the really fascinating and interesting technologies and distributed computing techniques and all the rest of it which are necessary to cope with that scale. But luckily for you, you can just kind of take it as read that a lot of people who really care about statistics and really kind of care about making all of these things manageable are taking care of a lot of those problems, which means that you and I can focus on, well, what are the things that we could be doing with this? And actually, anyone who's done any type of MI project, a lot of this is isn't going to be new. You know, the data that we're working with and the information that we've got at our fingertips and the scale at which we can work is going to be changing. But actually, you're still in this position where, I know you can't read this, where there's kind of 4 different sort of layers of analytics that you can do. So you can start with the basics, a descriptive set of analysis. So this is just you just asking the question, what is it that's going on today? You know, so and a simple one would be, how many phone calls have we had through to the contact center this morning? You know, it's just a really kind of basic stat. And then the next question, of course, is, okay, so why is that happening? And the thing that you're really interested in is, well, how is it different, and what is it that's driving those differences? So, oh, well, actually, we went live with our new e-forms yesterday, and they've just dropped off demand by 50% because people can suddenly get this thing done online, which previously they couldn't have. So you're then really into a set of diagnostic analysis, which is, well, what can I learn about the root cause? Then the thing that then starts to get interesting is the predictive set of analysis. So I know what's happened, I know why it's happened, so now what's going to happen next? And of course, that requires you to start feeding in all sorts of other bits of information. So you can, you know, at a simple level, you could say, oh, it's going to snow tomorrow, so we're going to get a load of calls around whether or not the schools are going to be open. You know, you probably didn't need a big, expensive, big data project in order to kind of tell you that. But that's the type of, that's where you start going from a position of, how am I just going to react to what's happening right now, to what is it that's going to happen in future, and then I can get one step ahead. And then the final kind of category of analytics, which is where it starts to get a bit more contentious, but also quite interesting, is where it starts to get prescriptive. So this would be the computer telling you, it's going to snow tomorrow, you're going to have 3 more people in manning the phones, because we're going to have this many more calls about what's going on with the schools network. And so they're the kind of they're basically the kind of 4 tiers of analysis. So what I thought I'd do is just kind of run through a set of fairly kind of novel applications of what are kind of traditional techniques, but using different data. So the first one is dc.gov, so this is Washington, D.C. So what they've had in place, I think for 4 or 5 years now, is they've kind of asked themselves the question of, okay, so how are we doing? And of course, how are we doing breaks down into how are we actually doing, and what is it that people think of what we're doing. And so what they've done is they've put in place this system which trawls a whole load of social media sites and says, okay, what is it that's going on in this environment? How many mentions are there of all of the different agencies that we're operating, and what are the words which are getting associated with those agencies, and are they positive or are they negative in sentiment? So this is just watching people's Twitter feeds and just kind of say, as an example, and pulling out how it is, what is it that they're saying, and how does that reflect on what's in essence a council. And then they pull that together with a set of traditional surveys, which I'm sure you've probably run a sort of periodic satisfaction survey to kind of get a feel for what residents think of you, and then pull that all together on a scorecard, which they publish on the website, gets updated every month, and it's basically a kind of weighted average of all of those things. And then they encourage people to go in, comment, and kind of feedback on what it is that's happening. And actually, it does give them, some of it works as you would expect it to, but there are some things where you kind of start to understand the disconnect, or they can understand where there's a disconnect between perception and reality. So I think there was an example where they had real concerns around the performance of their fire department and their fire safety services, but actually all of the sentiment and feedback coming through was amazing, because culturally, every time a firefighter saves your life, you're going to feel really quite good about it and get out there and start pushing that message. And then all of your friends are going to hear that message. And so the sentiment can often be very positive, but the performance can have problems, and also vice versa. But actually, being able to understand how that dynamic works is really important for the way in which they go about their work and the way in which politicians kind of govern the services that they're monitoring. So this is, and this is the sort of, and the amount of tweets and kind of social media feedback that they're able to gather is at a completely different scale to the number of kind of formalized checkbox surveys that they would be able to get done in the street, because this in essence costs them almost nothing, whereas every time you spend tens of thousands every time you try and get a formal survey done. So that's kind of descriptive. It's just how people are feeling. Then you can start to get a bit more sophisticated and look at kind of diagnostics. So this is a project done by Georgia State University. So obviously the education system is slightly different in the US, but what they were finding is that, nationwide, 1 in 3 undergraduates who start a kind of 4-year university course aren't graduating within 6 years of starting the course. And actually, that number, which is pretty horrible, 1 in 3.3, is even worse for black students. So 6 in 10 are failing to get through to completing the course. So they did a kind of fairly sort of traditional analytics project and just said, okay, well, what is it that, let's look at some of the stats on who's taking what and what credits people are accumulating and what is it that's actually causing this problem. And what they found is that the issue is that they have this open kind of system where you have your major and your minor, and you can kind of go along to whatever classes you want, almost in whatever sequence you want. And actually what was resulting is people were just picking courses where the credits didn't actually help them graduate, or they were jumping into a course that was too advanced for their current level of learning. So they thought, okay, well, we need to get ahead of this. And so they did this is where the bigger data project came in, and they went back and they said, okay, now let's look at 10 years worth of data and try and draw out of that what are all of the risk factors, or what are all of the factors which will predict to us that someone is likely to have problems passing their course, or they're going to fall, unfortunately, into this 1 in 3 category. And so they came up with their algorithm, and it had 800 different variables. So this is not a kind of, are there 2 or 3 things which are making a difference? They took 800 different variables and said, right, let's just throw that at the computer and using these big data techniques and get it to work out what is it that's actually important. So what are the correlations which tend to drive issues? So it processes those 800 variables for 30,000 undergraduates every night. So this is this thing about, we need to react quickly. This isn't the sort of thing where you want to pick it up at the end of the semester and go, oh, you haven't really made much progress. And they've ended up with over, I think that's kind of around about 50,000 actions or interventions that got prompted over the first 12 months. And they only need to be little things, like have a chat with your tutor about this, or you need to, this course is better suited for where you are in your academic studies at this point in time, or did you know this isn't going to help you acquire credits towards graduation? They don't have to be big interventions. For some people, obviously, it's a more structured, you don't understand how you're going to graduate, but for a lot of people, it's just that nudge that you've made a slightly wrong decision. And actually, for the 2016 graduates, they took an average of half a semester, so half a term, off the time to get to graduation, which means that their students saved, $15 million. So that's across 10,000 students. So it's, these are significant savings, remembering the funding system that's in place in the US, and it gives the university obviously the satisfaction that they're doing a better job of educating, but also in a competitive market makes people think, actually, that's where I should go and study. So you can imagine, it'd be interesting to see, well, where would that take secondary school students here. Okay, so that's a bit on. Okay, well, we've understood what the issue, where things are at the moment. We've kind of got our heads around what it is that's causing it, and started to take some action when we see that that's happening. What about understanding what's going to happen next. So this is a project that Tower Hamlets did with Mastodon C. It's a company started by a friend of mine, and they did, and they were looking at special educational needs provision and going, we've got a problem, we're not happy with the level of provision that we have right now, the travel times for some of the people that need to access it, being able to access it, aren't right, but fixing it requires big capital investments. You know, we're going to need to work out where do we put these education centres, what adaptations should we make to existing schools. These are not cheap interventions to make. So we need some certainty around, well, how is it that demand is going to develop over time? So they've done this project just looking at what is it that drives demand. So you need to look at not just kind of the performance of the schools or the size of the population, but how is that population going to change over time? What proportion of it is going to be people that have been in the local school system all their life versus people that are coming into it from outside? Where are the people who are most likely to have special educational needs? Where are they likely to end up living, given trends in house pricing and developments of new social housing? And they've kind of pulled all of that together and put together an algorithm which allows people to kind of play around with the various different interdependencies. So how much capacity do we have? What level of pupil experience is it that we need to be able to deliver, and how much money have we got to spend, and understand how that in turn kind of pans out and gets you what that provision looks like. So it's not prescriptive. It doesn't say your special educational needs provision should be this, but it does allow the officers and the members to look at what the different variables are and how it is that they're going to actually impact on the day-to-day lives of some of the most vulnerable people in the borough, and think again as well about, well, what's the impact going to be longer term? You know, if we don't help them get to education, what's that going to mean for their employment prospects, and what's that going to mean for our ongoing relationship with these customers? So that and it's made a really big difference and allowed them to make some fairly big investments with confidence that they've thought about all of the different factors, they've mulled through all of the different variations, and they've kind of got to they've got to the conclusion which they think is the right way forward. The interesting thing from speaking to Fran about this is that this is not the data you just put in the data and it all just comes out. Getting this right and tuning the model was a really iterative process. All of the people who are actually working in those services were inputting to it, and that not only means that you end up with a better model that understands a lot of the nuances and where the data might be a bit misleading because of some historical quality issue or a change in standard or something else. It also means that you get that extra level of buy-in and commitment to what the results turn out to be. Okay, right, one more. This one's, this is where it starts to get a bit contentious. So there was a kind of group of social scientists or statisticians, and this study was originally done in New Zealand, and then the results applied a bit there, but also heavily in the US, which I'll kind of come on to, is looking at what is the how well can we predict which children are going to require a intervention in order, a safeguarding intervention, basically. The terminology is a bit different for them. But how well can we, based on the data that we have, how good a job can we do of predicting which ones are going to require a safeguarding intervention over the next 2 years? And actually, I won't kind of go into a lot of this, but the result, that the algorithm that they came up with was as good as the breast cancer screening is at predicting or preventing the development of breast cancer. So it's certainly not foolproof, but actually a fairly it's just almost frightening. Actually there is an awful, just unlocking the data that was already held can give you a diagnostic as to what is likely to happen in that child's life. So this has then got kind of rolled out in, most of this stuff seems to happen in America for some reason, or either that or I'm just not, my searches in Spanish or something aren't particularly good. But what they did is that they worked with the same group of scientists and said, okay, let's just focus on one bit of the journey, because that's just a bit too contentious for us, kind of turning up and going, knocking on the door and saying, you know, the odds are that there's going to be a problem here, so we're going to have a look around. They instead said, okay, let's look at the number of referrals, the referrals that are coming through the door. So they have a kind of similar sort of referral system. If you've got a problem about or some concerns around the safety of a child, you can ring through to social services, and they will kind of screen that. And they have a kind of screening method where there's an assessment of, is this low risk to high risk, or they have or some people get automatically passed through because the where it's basically a professional, so like a teacher or a social worker or a healthcare professional. They're kind of trusted in effect to make good judgments, and therefore there's kind of an auto referral for assessment in place there. And what they did was they started kind of looking at, okay, well, what is it that how good is it? How good is that process, or how effective is it? And this is where these statistics are not going to be particularly helpful. Which one can you reread? Yeah. So this is let's just kind of look in the. So this one in the top right-hand corner. This one is kind of looking at okay, your existing. They were looking at how the outcomes developed over time. So you get the initial referral, and then you either go and do an assessment, or you decide actually it's not worth doing an assessment in this case. We're just going to put it on the record, and then we'll kind of move on. It's insufficient evidence to warrant going out and seeing somebody. And so they looked at the methodology that they had. So the methodology that they had for doing that assessment gives you this lift ratio, which is this. We should send these slides out afterwards, and I'll send out all the links because the papers are amazing. The lift ratio of 9 to 1. So that's saying that the existing assessment method, if you get rated as very high, then you can be. It's like 9 times the average of likelihood that actually an intervention is appropriate. Whereas if you rely on the computer, then and its view on what the risk factors should be, then it gets you to 23 to 1, and that's without having to train everyone who's answering the phone, relying on, are they tired, are they not tired, what is it that's how many people have we got available. If you just pass everyone that comes through for referral through to the computer, it will do a 2.5 times better job than relying on a person's assessment through a structured methodology alone, and which is staggering, really. And actually, what they think is the cause is that the computer can check all of the family history, all of the relationships, all of the backgrounds of all of the other people who happen to be living in that household. It basically has access to everything that you ever know about, or that the authority has ever gathered about that person, in a way which would require someone to do hours and hours and hours and hours of research and not confuse it with another case, not confuse it with another person. And it's just one of these things where actually computers are, what they're really good at with these big data techniques is just sifting through huge amounts of information and pulling out things which it's just not possible for you to be able to kind of hold in your memory, particularly not when you're on the phone going from traumatic case to traumatic case to traumatic case and getting kind of hammered with it every day. So obviously this is not without its kind of political challenges, and the researchers have actually been, and it's always kind of used as a decision support tool. So this is around, how quickly or how important is it to go out and do a formal assessment, as opposed to people knocking on the door, sort of Minority Report style. But you've got to kind of think, if we can do a 2.5 times better job, I know that's a trivialization, but if we can do that much better job by having the computers to help us, then isn't that something that we should be doing? And then a slightly kind of more simplistic example, a kind of less contentious, which is just showing how some of these things are really driving kind of day-to-day business in private sector organisations. So this one is the energy market. So I'm not going to talk about the goods and bads of the energy market, other than to say, if you look at this graph is basically just kind of showing movements of different prices for energy companies, and they are repricing dynamic tariffs day after day after day after day in order, basically just saying, okay, well, what are our profit margins? What's the future likelihood of someone staying with us? What's the likely direction of travel for the energy tariffs? And this is and the same thing with airline tickets. This is no longer someone sitting there going, okay, well, the price of this should be this. This is the computer kind of saying, actually, yeah, I understand what's happened in the past. I've got a model that tells me how things are likely to develop in the future, and therefore I can optimize exactly what the price of something should be at that point in time. So I'm sure Andrew would love to roll it out for his garden waste service down in Aylesbury, but we might be a few steps away from that. But this really can be the sort of thing which can drive minutiae of decisions on a kind of day-to-day basis. And this is just how it is that the energy companies are using it to drive pricing, and why it is that it can get so confusing from a consumer perspective, but is from their point of view, they're optimizing for profit. So a different outcome, but you can see the commercial incentives are driving much faster take-up than people moving more carefully looking at social incentives. Okay, so I said I'd talk about AI, so what about the robots? Now, the key thing with artificial intelligence is this is definitely, the marketeers have definitely taken over now. So when you hear AI, you could probably just go, okay, there was some sort of algorithm or some sort of automation, and therefore, they're just now spinning it as AI. It's getting to the point where I can say, well, I pressed print on a print job, and then it came out of the printer automatically without me needing to do anything. It's getting slightly ridiculous. But actually, the thing that kind of tends to get the controversy, and the thing where it starts to get interesting is when you start getting into machine learning. So machine learning is kind of right on the crossover of what people think about as big data and what people think about as artificial intelligence. So, and the key thing here really is that things will start to feel like artificial intelligence when you no longer feel like you're in control of it. So this is, and it is really a kind of control thing. So if I'm telling the computer, if this, then this, then it's fairly kind of straightforward. And people will badge that as AI. It isn't really, but but often it kind of does get badged that way. But the thing that makes it feel to me like AI is when I'm throwing a set of information in, and then I'm almost getting asked questions back, or the computer is responding to feedback. So I'm saying, yeah, that's good, or that's bad, or that's a fair match, or that is a spoon, or that isn't a spoon, and then it is automatically updating all of its internal rules to say, okay, I now need to accommodate that new bit of information. So this machine learning is much like when a child is learning what's the difference between a banana and an apple. It's like I see a lot of bananas, and then I get told they're all bananas, and then I see something that looks a bit like a banana. It's not. It's a carrot or whatever, and then I respond to that feedback to say, no, that's a carrot, not a banana. And you're not saying, oh, look, it's a banana because it has a curvature of this ratio. The skin feels like this. That's not how children learn, and that isn't how machine learning algorithms learn, which is why it then makes it feel like, actually, yeah, no, we're delivering artificial intelligence. And then I guess related to that is saying, well, I'm not giving you a structured input. I'm just giving you a whole load of information. So kind of Mastodon CEO I mentioned earlier, they did a project where they just got a whole load of clinical care files, no information other than just here are the documents, and just kind of went through that and trawled out a whole load of kind of interesting insights. but that's the sort of thing that that will feel like actually, yeah, no, we're doing an artificial intelligence project. So that's why the crossover tends to sit, is that it's unstructured data, there's large amounts of it, there's an algorithm that is kind of churning away in the background and optimizing based on some feedback. But you know, if you want to be stricter about it, you would go back to the Turing test and say, okay, can I still tell it's a computer if I have a conversation with it? And something that's telling you if something is a banana or a carrot isn't going to be passing that test. Okay, so hopefully, you know, some of those examples have caught your eye, and there's some things that you would want to get, you would want to kind of look into and think, how could we apply them here? So these are the kind of, I guess, sort of 4 top tips for kind of getting started, really. So the first thing is just make sure you're really clear on what the issue is that you're trying to solve. So it's no point just saying, oh, we're doing data, or we're doing a business intelligence project, or we're just doing better use of data in the organization. You need to have a really clear business goal in mind and saying, okay, how is it that working better with the data that we have and that others have could get us towards that outcome? You need to just kind of think afresh at when you're kind of mulling over, okay, well, what are the different sources of information that we have available to feed into this? So kind of go, you know, previously it was just like, oh yeah, well, draw me a nice dashboard of the number of these over time, and it's just, here's my relational database, or here's my, and you know, just work with that. This is other sources of information, so it's what have you got in your documents that might be useful, what have other people got in their documents that might be useful, what could be on the internet, what sensors could we feed in, what weather information, you know, really cast the net wide and think, well, yeah, what are all of the things which might be relevant here so that we can test them. Make sure you get all of the right skills and expertise together. A lot of this stuff is non-trivial, so it's worth, at least whilst you're getting started, to kind of get some experts in to give you some advice and kind of guide you through it. And then finally, just make sure that you are continually evaluating what you're doing and learning. And this, I mean, this probably applies to everything that you've kind of heard talked about today. There are no silver bullets with this, and I've got this link is an effort which was made in housing, just trying to kind of pull together a predictive algorithm for development of rent arrears, I think it was. Or no, it was, they initially wanted to look at the number of repairs. So how can I tell how many repairs I'm going to have of a particular type across my housing stock? And then I can model whether or not I should do preventative maintenance, and I can see, you know, what that's going to save me over time or improve in terms of customer satisfaction. And they, you know, it just failed spectacularly. They disappeared down a hole of not being able to get stakeholders properly bought in, the data arriving in 100 different formats, the technology required to do the translation between different formats of data capture just being too difficult for them. So, you know, it's worth. There's, you know, I've talked about some of the successes, but there are failure projects of this type, just like any other, that haven't worked out. So I would, you know, as well as looking for the inspiration of what's great, also look at what are some of the pitfalls, or what are some of the lessons that other people have learned that you can take on board as a head start. And that's it. Thank you. Yeah, I'm happy to take any questions now, or I'll be around for a good sort of 15-20 minutes if anyone fancies a chat. Any questions? Amanda's got the mic. She's dying to give it out. No? Okay.
You happy to stay for a little while?
Yeah.
Yep. I know Peter's got a flight to catch, but I think we've got about 20 minutes before you need to go.
Yeah.
Okay, thank you. That was fantastic. A lot there. Thank you, everyone. Again, Peter Dewsbury.
Thank you.